Hi guys, welcome back. This is our first lesson on circles in the coordinate plane, and it's a possibility that we're kind of combining this with the other circles lesson, so let's just get this one started. This should be a pretty quick lesson. So first of all, we have to introduce you to a new formula, and it's called the standard form of a circle in the coordinate plane. That's quite a mouthful. So I'm going to try to write this kind of in a color coding notation. So x minus h, sounds familiar, I know, quantity squared, plus, and then in another quantity, we have y minus k, quantity squared, equals, and this one's kind of weird, but it makes sense once we think about it, r squared. Oops. So the parts that I put in colors, other than black, are integral parts to the circle. So if you think about how do I graph a circle, I need to know where the center is located, and I have to know how long the radius is in order for me to create a circle. So that's what you're coming up with here. So speaking of those pieces, we have our center being located at the ordered pair h comma k. And then our radius, I'm sure you guessed this by now, our radius is going to be length r. So the built-in negatives for both of the components, I'm sure you've kind of noticed something weird about math. If there's something grouped in parentheses, usually there's a built-in negative as part of the transformational formula. So there's two built-in negatives this time for h and k. The radius is just r, so we'll talk about what that means in the formula coming up here. And that's our first task. Let's identify the center and the radius. So your center is going to be located at an ordered pair every time. And then your h value and your k value should be pretty obvious, but we have to remember those negatives are, the subtraction signs are built into the formula. So your h is really a positive 2, and your k is really a positive 1. So your center is located at 2, 1. And then remember this number right here, this is radius squared. So if you think about, okay, radius squared is 25, so that means your radius length is just going to be a 5. I don't know, units. We don't have a label on this, obviously. What we're kind of building towards is can you graph it in the coordinate plane. So similarly here on number 2, you should be able to identify the location of your center and then the length of your radius. So if I think about what's really happening in this parenthesis, remember the formula is x minus h. So for it to become an x plus 12, that means it's really x minus negative 12, quantity squared. So when I ask you who's h, you're going to tell me negative 12. This kind of comes back to the opposite idea that some of you had earlier in the unit, where you were thinking, oh, anything with the x was opposite because of that built-in negative. And I understand what you're going with, but we know the real reason is there's a built-in negative. So similarly here, this k value is a negative 8. And if you want to rewrite that for your notes, you would see something like y minus negative 8 squared. So then our radius, remember this is radius squared. So the radius length is the square root of that, which would be a 7. All right, moving along, easy enough, right? So of course they got to throw one that's kind of weird at you, number 3. It seems to be like it's missing something. It almost seems like, you know, oh, I'm supposed to be subtracting something, but there's nothing there, so that must be a 0, right? And then the same thing happened here with the y's, or the k, I should say, y minus 0 squared. And then 225, remember, is r squared. Now, what I'm going to do here is, and you're welcome to do this, instead of writing it as 225, I'm going to write it as 15 squared. I have that perfect square memorized, but you could have square rooted in your calculator as well. So now you can really clearly see the center and the radius, especially if you're using the same colors that I am. So, for my friends who are looking at my notes later, I'm going to keep my colors going. The center is at 0, 0, and the radius length is 15, because we already kind of square rooted it when we wrote it in that notation. All right, this next time I'm not going to rewrite it. We're just going to kind of go off of pattern. The center is located at negative 6, built-in negative, positive 15. And then, of course, got to throw a weird one at you again. You might be asking yourself, oh my gosh, 7, what's the square root of 7? And that's your answer, it's the square root of 7. Now, if you were graphing this and you had to approximate it, square root of 7 is, if I think about my perfect squares, it's in between a 4 and a 9, right? So it's something bigger than 2 and less than 3. So 2 point something. if I was graphing this or if I was trying to match a graph without a calculator. All right, this next task is what we just did, but in reverse. So I'm going to give you the center and the radius, and I want you to throw it into the formula. So my formula, and I don't mind if you start every single question by writing what I would refer to as the skeleton of the formula, and then kind of clean it up after that. So this is weird because you got that weird center and radius, or center, excuse me, of 0, 0. Your radius is the square root of 35. So when I throw that into my formula and I think about, okay, how can I make this look prettier? Well, we'd never say x minus 0. We just say x squared and then plus y squared. And then I wouldn't say square root of 35 squared. I would just call that a 35. Similar idea on the next part. We have our formula, which is x minus something squared plus y minus something squared, and then it equals r squared. So if I put in my information here, h is negative 6. So I'm actually going to do this double slash thing where I just go ahead and make it a plus sign. Same thing here. And then our radius is a 6 squared. So kind of rewriting that so it's pretty. X plus 6 squared plus the quantity y plus 8 squared equals 36. There's a great answer in standard form. If you are lucky enough to take the SAT in the near future, they do love these questions on the SAT. And we'll discuss this topic again, if not in the very near future, the semi-distant future when we look at quadratics and completing the square. So now I'm going to give you a picture and I want the formula. It sure would help if I knew where the center is and how long the radius is. So I'm going to kind of eyeball it, but I'm thinking this is the center right here. And if I can apply an ordered pair to that, I would see that this center seems to be located at -1, -2. But my eyes have deceived me before, so apologies if that's wrong. Now the length of the radius, it's your choice which part of the circle you go to, but you want to pick a north, a south, an east, or a west. So I'm just going to go easterly here. And that's a distance, okay, from here to here, that would be 5 units. Would have been the same distance if you went up or left or down. So the radius is 5. And if I throw all that information into my formula, that's going to become an x minus a -1 quantity squared plus y minus a -2 quantity squared. And then this time I'm going to save myself a little bit of time in ink. Instead of writing 5 squared, I'm just going to go ahead and call that a 25. And there's your standard form of your circle. Bet it's another graphing one. All right, here we go. The center is located at, let's see, this guy right here. Now careful, that ordered pair is 0, -3. And if you have already gotten really good at these and you can already tell, like, this is what my formula is going to look like without kind of mapping it out, that's fine. But these are your notes, so it doesn't really make sense for us to skip a step here. So if I'm going from the center to one of the edges, and apparently I'm always going to go this way, it went from a 0 to a 3, so that would be a distance of 3. This one was kind of marked up weird with the boxes. Some of them were half blocks, so you got to be careful there. All right, I think even I am ready to go into my formula now. So I have no problem with you guys saying x minus 0 squared. I would not count that wrong at all. And then here we're going to end up with y minus a -3, so that'll become a +3. And then the radius being squared, instead of calling it 3 squared, I'm going to jump ahead and call that a 9. However, the best answer, I'm sure y'all can tell, would be an x squared plus a y plus 3 quantity squared equals a 9. Very nice. All right, so that is the first lesson for graphing, or I guess the standard form of a circle in the coordinate plane. We didn't do a lot of graphing there, thank goodness, because if you see my graphs, you'd know what a circle would look like, and it wouldn't look like a circle. But there's a follow-up lesson to this coming up in the curriculum where we're going to complete the square, okay, a little foreshadowing for you, to graph the circles or to write the equation of the circle. All right, good luck, everybody.